Let us discuss about Gaussian elimination. Method using pivot element. Let us write the three equations in terms of three unknowns like this. Now these three equations in three unknowns, since they are linear, they may be represented simply by the augmented matrix this. Okay. So we will work with this augmented matrix only, and we will assume whatever be the dummy variables are, we are going to solve for it. Now what is the pivotal element concept? Pivot element is the highest numerical value of all these coefficients of the three variables. We assume that whenever we rearrange the matrix in this augmented form, this A11 is the pivot element or the numerically largest element, and we move on to eliminate the variables as to our choice, so that we can find out the values of all the three unknowns. So what is the primary target? Our primary target will be, let us write it as R1, R2 and R3. As we know that this is our pivot element, our primary target will be to make it 1, and we divide with this largest numerical value all the other elements of R1, and we have the new R1 as this. Fairly simple, isn't it so? We just divide R1 by the pivot element and we get the new R1 prime, and then we use this new R1 prime to eliminate the first element of R2. So to make this 0, we must multiply this new R1 prime with A21, isn't it? So if we multiply this with A21 and then subtract it from R2, then we get R2 minus R1 prime into A21, and this suffices to make the first element of R2 prime 0. I hope it is understandable. So what will be the second element? It is nothing but we are subtracting from R2 R1 prime into A21. So it will be A22 minus A12 into A21 by A11. And similarly, whenever we subtract from A23, let us keep a bracket here, we subtract from A23 minus, it will be A21 into A13 by A11. So this will be the new row 2, and similarly this element will be B2 minus B1 into, we have multiplied R1 prime with A21, so B1 into A21 by A11. So this is the new R2, and similarly in case of R3 also, we multiply row 1 prime with A31 and subtract it from R3. So we have the new R3 prime as the old R3 minus the new R1 prime into this A31. Isn't it so? Only this operation makes this element 0. We have multiplied this rho 1 prime with A31 and we have 0 here. So what will be this element? This will be nothing but A32 minus we have multiplied it with A31. So it will be like this, and similarly this will be A33 minus A13 into A31 by A11, while in the augmented place we have B3 minus B1 into, we have multiplied it with A31, it is written here, by A11. So we have reached this stage. Okay, I would like to write this second stage with a bit of manipulation. That is nothing, just to make it understandable, we use 1 0 0 in the first column, then we have A12 prime and A13 prime and B1 prime in place of R1 prime. Similarly, A22 prime, A23 prime and B2 prime in place of R2 prime, and A32 prime, A33 prime, B3 prime in place of all these values. Fairly reasonable, isn't it so? We just represented R1 prime, R2 prime and R3 prime with this new nomenclature. It will serve a good purpose for us. Now our target will be to reduce this second stage of augmented matrix to the third stage. And what will be our intention in that? This is the second stage. We have 3 new rows of that augmented matrix. And in the third step, what we intend to do is that we leave the first row 1 intact. We don't change the first row. We just divide by this element this second row. It may so happen that this element is 0. In that case, we will have to shuffle and choose a non-zero element in this place. Otherwise, we will not be able to divide with this element. Our target is to make this unity so that this becomes A23 prime by A22 prime. Here we have assumed that this is a non-zero element. If this is not a non-zero element, we will have to search for a non-zero element, and then this will be our new row 2 double prime. Remember, R1 prime is same, but R2 prime has changed, and we have divided R2 prime with nothing but this element, which is assumed to be non-zero. And what is the purpose? The purpose is that we again eliminate this element from R3 and we get new R3 double prime as the old R3 prime minus the new R2 double prime into this element. Fairly simple. That is our purpose. If we multiply this new R2 prime, R2 double prime rather, with a 3-2 prime and subtract it from R3 prime, it becomes 0, and this becomes A33 prime minus A23 prime into, we have multiplied with A32 prime by A22 prime, and we have the new element of R3 double prime as this. And similarly, we also subtract from B3 prime this into A32 prime, which makes it B2 prime A32 prime by A22 prime. So we reach the third stage, in which we may nomenclate the new rows as R1 prime which has been unchanged, while R2 prime is changed and it becomes A23 double prime, and this becomes B2 double prime, isn't it so? And in place of R3 we have 0 0 A33 double prime and B3 double prime as R3 double prime. Okay, so this is our new matrix, and this we can rewrite as, we are going to rewrite it as 1 A12 prime, A13 prime, 0 1 A23 prime and 0 0 A33 prime. Our dummy variables are intact, they are x, y, z, let us assume, and we have in the augmented place B1 prime, then we have B2 double prime, and we have B3 double prime. So this augmented matrix may be represented as this, and if we write down the three separate equations, we easily find that three equations becomes this, from which we can easily, the first one is x plus a12 prime y plus a13 prime z equal to b1 prime. The second one gives 0 into x is 0, 1 into y is y, plus a23 prime z is equal to actually b2 double prime. And the third one is nothing but 0 into x and 0 into y gives 0, and z into a33 prime is equal to b3 double prime. Actually these are double prime elements, isn't it so? So we have z as nothing but b3 double prime by a33 double prime, and whenever we get this value we plug it in the second equation to get y, and whenever we have y we plug it here and z here to get x. So that is precisely the method of Gaussian elimination by pointing out the pivotal element. Okay.